Hi guys, welcome to my YouTube channel, and in this video I will briefly discuss about application of Gauss's law. The first application is about the electric field intensity in a hollow sphere. It means that I need to calculate the electric field intensity in a hollow sphere. So this E belongs to electric field intensity, and hollow sphere is a hollow sphere in which we will draw an ordinary or arbitrary or imaginary boundary. In that imaginary boundary we will place a hollow sphere. So this is the first application of Gauss's law, which is stated that electric field intensity in a hollow sphere. So in this case we need to focus on a hollow sphere, and which this sphere will be hollow. There will be no solid boundary between or inside it. So in that hollow sphere or imaginary boundary, a hollow sphere is there, and positive charge is distributed in that boundary, and this hollow sphere is known as a Gaussian surface or Gaussian sphere. This is a hollow, and in that hollow sphere no electric field lines or no charges are present here. In order to understand the electric field intensity or the electric field effect, first of all we need to calculate the electric flux in that hollow sphere, because this hollow sphere is a Gaussian surface, and from center to the outer surface is known as capital R, and from center to the hollow sphere or boundary of hollow sphere is known as R prime. So as you have seen that R prime is less than R, value of R, because there are two circles or two spheres, one having sphere radius r and one having radius of r prime, and there is a positive charge distribution or equal distribution on the boundary of the hollow sphere, or which is the arbitrary or imaginary boundary. In this case we have seen that all the positive charge are equally distributed, and inside it, when these positive charges affect, they cancel out the effect each other, because positive charge can repel each other. So the number of electric field lines passing through the center or the in the region of r prime, or in this region I am marking this, in this region electric field lines can cancel each other, or because these electric field lines moving in this direction, and due to equal distribution or regular distribution they can cancel each other in the central region, the flux will be 0 and E will be calculated. So the formula of flux is equal to E multiplied by A, or E dot A. In this case we have seen that the flux is 0, but in this parameter there are two different parameters, electric field intensity and area, which can be 0. So as we know that area cannot be 0, because we have physical explanation of area or sphere. This sphere is visible, so as you have seen that it have radius r, and the upper sphere or largest sphere have radius capital R, and the smaller sphere which has a radius of r prime, both have radius. It means that area is dependent on the value of r or r square, so this area cannot be equal to 0. So the flux is 0 in this case, which means that electric field lines in the central region or the electric field lines in the Gaussian surface are 0. Electric field intensity is 0 in that region. This is the only possibility in which we can conclude that flux, when the flux is 0, or in the case of flux 0 in the central region or the Gaussian region, only electric field intensity or electric field lines are 0, or there will be no electric field lines present in that Gaussian surface. Due to this, because the area is not 0, or area cannot be 0, any physical quantity or any physical thing or any physical sphere, because the sphere is dependent on radius, area of the sphere is dependent on radius, and area cannot be 0. Or in the other case we have a formula, flux is equal to phi is equal to q over epsilon naught. So charges are equally distributed on the upper surface, but inside it, or inside the small or hollow sphere, these charges or electric field lines can cancel each other due to their direction of propagation. So that is why charges can be 0, but and flux is 0 in this case, and area cannot be 0. In order to further explanation of the Gauss's law, which states that Gauss's law is equal to, or the flux of that body or flux in the arbitrary body is equal to 1 over epsilon naught times the total charge contained in this region. So this is a this region, or this upper boundary is contains of positive charges, so it will be acting like a shield in the hollow sphere, because all positive charges are equally distributed in that region, and this is the first application of Gauss' law. In the next lecture we will discuss about the second application of the Gauss' law, which is the infinite sheet or electric field intensity of the infinite sheet. Up till now we have finished about the application of Gauss' law, or if you have any question related to this, you can contact me at this number, and you can comment on the comment box. Thank you.